Resuming content. We are moving on to the third tool, Maestro. So the problem Maestro solves, and there's been a lot of foreshadowing here up to this point, data dependencies. Do you have tasks in some kind of order important pipeline? Something needs to run before something else can run. There's some kind of intermediate file between them. There's a producer and a consumer of information, reprocessing, analysis of results, whatever. Things that can't all run at the same time. You can do that in Bash by hand up to the limit of what a human can type and keep track of in their head. You know, tens of things, 100 things, maybe, as long as it's simple enough. But as that grows larger, as your pipeline gets longer, as you're running more things at the same time, then things get more fragile, harder to keep track of. You're more likely to run into edge cases, problems, failures, whatever. Maestro is adding directed acyclic graph-based dependency management. And you write these YAML files to declare your tasks and how their relationships between each other. Yet another markup language is what that stands for, but you're writing a text file and there's a particular syntax that you stick to, and there's the magic words that you use that Maestro reads and interprets and uses to build the DAG. Maestro is a culturally Lawrence Livermore National Laboratory tool. That's where it's developed. They run HPC as well as NERSC, in addition to NERSC. They have some cultural tendencies as far as when they're writing software. Like they developed the Flux scheduler. They don't use Slurm, or they're phasing out Slurm. So their tools tend to be more Flux native than Slurm native. And there's a couple things that are a little bit of an extra challenge as a result of that. Yeah. All right, directed acyclic graph. So the nodes in the graph are the computational steps, and the edges are the dependencies. You've got an arrow that says this step has to finish before that step finishes. Acyclic, no loops, actually turning the graph into a schedule without accidentally getting stuck in an infinite loop is the constraint being applied here. So this is something that the resolver needs to actually turn the graph into a schedule of what runs when and what runs after and that sort of thing. There are a handful of workflow management tools that intentionally allow cycles in the graph. And there is some utility to that. Like say that you've got a simulation where you're waiting for something to converge and you don't know when it's going to converge. So you might have a cycle in your graph of tasks that says, run my task, take the output, see if it converged. If it converged, then move on with the rest of the pipeline. If it did not converge, then rerun the task. That's a cycle. Maestro is not going to be able to, it's not going to have an easy time encoding that kind of dependency into your workflow, but there are some other tools that can. Yeah, and as far as like a formalism that is present in workflow management tools, lots and lots and lots of different tools have support for DAG representations of pipelines and workflows. It is very common, and you will be able to find a wide range of other characteristics for the workflow that include this feature. So if you need DAGs to express your workflow, but there's something about Maestro that's unsuitable for you, then there are other tools to check. You're not out of luck yet. All right. Multi-step workflows with dependencies, pipelines, data dependencies. You can do you can also do parameter sweeps in Maestro. Your scale goes up to hundreds of steps, and your numbers of jobs can go up to hundreds, thousands-ish. Maybe you hate Bash for some reason and you're happy writing YAML. This is a good choice for you then. So if you need to scale up even larger than this, then you're going to want to upgrade to Merlin. Or if you need to use more than one node to get done in a timely manner, Merlin will do that. And if you need the history record that Ada provides. All right. First example. So what do these YAML files actually look like? So there's 3 top-level sections that you have to include. The description, which is basically like, the metadata of what is this thing here in this file. The env section, these are variables as key value pairs, and you can reference those later on by using this $name syntax. The study is where you put your actual work tasks. So you list your steps, they get their name, identifier, a description, and a run block, which is going to be describing what the task is actually going to do. So you put a run.command inside your study run blocks, and that's the actual definition of what's going to be run. Your run.depends that's where you give it the names of the tasks that have to be finished before this one can start. If it's something that has no dependencies, you can just run it straight out of the gate, then you don't actually need the depend step. Yeah, that's it. Okay. Tokens and data flow. So the root location on the file system where your workflow is running is determined by wherever your YAML spec happened to be. So if you've got multiple pipelines, then you put your YAML spec in like each its own directory, and you can run them in the same you can run them from the same place and give them that directly location to the different YAML. And spec root will populate the path and understand that this is a pipeline that's being run in a particular location, even if your terminal that you're using as a human may not be in that location. Workspace refers to the output directory for a particular run step. So that is how you're keeping your outputs organized for a particular piece of computation inside your node graph. If you are in a particular step and you need to refer to a location that belongs to a different step, then you use the step name.workspace notation. And so that's how you can do things like, well, my input is supposed to be in this other location. I have a configuration file that was from this other location, or I am writing a side output for future use in a different step to this other location. Also, you can have custom tokens that are not related to other steps or anything. They're like environment variables for your workflow, and that was defined back up in the environment section, and you can access those with the same notation. So you're getting the ID name from that environment variable. So this is another workflow tool where the state is partially being stored in the file system. The presence or lack of files is going to be meaningfully interpreted as Maestro is deciding what to do as it's processing the workflow. And you also have sort of this previous and next step kind of notation that you can use for things that are chained together. Okay. Each step is its own process, and that goes along with like how the run dot command is like this was a Linux command, and that's what you use to define what your task is going to be running. Okay, declarative versus imperative. All right, so the distinction between declarative and imperative is in earlier, less advanced ways of defining workflow, you are going to be, as the human, writing exactly what you want to be happening at each step. Run this command, run that command, copy a file over, run a third command. You're telling it exactly what to do and in what order. This declarative model, each node is saying, I have these requirement steps before I can get started. And that gives you the arrows in the directed acyclic graph. And so as a human, you only have to worry about the prerequisites for each step. You don't have to worry about how they fit together. Maestro takes care of that part. So the overall scheduling gets done for you with automation, and you only have to worry about like, okay, well, I have a blast job that I need to run, and I need to make sure that I have my FASTA file ready to go, and I need to make sure that I have my reference database ready to go. But you don't have to worry about any of like, okay, well, before that, the reference database needed to be created by another task. And that information is stored in the relationship between the reference database and whatever task you wrote that generates the reference database. You don't have to think about it at this later point in time. Okay, so Maestro run workflow YAML. Like Signac run and like GNU parallel, you're starting a process, and that process in its operation of memory is what's going through and resolving what runs and makes the decisions to actually turn the YAML file into ordered computations that get issued and run. Okay. Outputs. So the status command is what's giving you the equivalent of your exit 0 or otherwise, or your labels from Signac. So you can inspect and tell if steps are running, if they're not started yet, if they're finished, or if they failed. The actual runtime. So different tools dealing with DAGs. There's two architectures for dealing with this. There's either a static build, which the tool will take a look at all of the declarative dependencies and write the schedule immediately, and then take that and move that to the next phase where things actually run. And there are dynamic tools, which will just look at dynamic steps individually, or just, it just looks at the defined tasks individually and checks, oh, does this one have its prerequisites ready yet? Okay, I guess we can run that, and then moves on to the next. So this dynamic scheduling makes things more adaptive. It can give you some flexibility with sort of load balancing, but it can also be sort of more brittle or risky. You have to watch out for the tool has to watch out for cycles. You would not be, as a user, watching out for cycles at that point. Usually a tool will throw an error if you try and give it a dependency graph that does have a cycle. All right. parameter sweep example with Maestro. Global parameters. So much like how you give dimensions to SIGNAC with a set of parameters, this global parameters block gives you a way to define sets of parameters and pass them to SIGNAC or to Maestro. So you have a values list, and there's a format string for like the label that will be used to refer to it as a dimension. And the formatting for doing that, you have these percent sign, which is used to actually substitute in the value. And that gives you the string that you put inside the $sign format for when you want to actually refer to a particular step somewhere else in the workflow. So if you have a later task that you want to be dependent on the completion of size.20, then this is how it gets constructed that you can refer to that. Yeah. Furthermore, the expansion is built into Maestro. So if you skip the dot and the parentheses, then a step that just uses the identifier is going to actually give you 3 steps, and it's going to give you one of each version. It's going to give you .10 and .20 and .30. That lets you sort of expand things out programmatically without explicitly needing to write every single step of something that you're doing like 10 times with just changing one number. And you can get Cartesian products in the same way that we were with previous tools. Right, okay. All right, fan out, fan in as a design pattern, or scatter gather. So you start with one step definition that using that size dot whatever, you can fan out into n different tasks, each with its own value from the size list. To pull that back together, once all of those tasks are complete, you can use these wildcard characters. So you end up with step underscore wildcard, and that is going to hold as dependent all of the possible values for step and expect each one of them to be finished before whatever step you're defining as your aggregator actually is allowed to run. Okay. So run many simulations or something else in parallel, each with their own set of parameters, and then you want to aggregate them all. Maybe you want to process it for some sort of statistic relationship or get the average or whatever. So when you're getting over SIGNAC, data dependencies, pipeline structure, ordered task execution with some flexibility for programmatically expanding things beyond what you can write in the YAML yourself one at a time. All right. Maestro has not perfect, but better Slurm integration. There is a batch block that can be used as the bridge between writing these YAML files and what is being sent by Maestro to the Slurm scheduler. So you've got the batch block. You tell it the type, it's Slurm. You can tell it the host, we're on Perlmutter. Bank is the term that might be like a Lawrence Livermore cultural thing that they use as vocabulary, because we'll say account or project. They say bank. Train 3 today. Now, here's one of the weird gotchas. Q, if you don't put Q in, then Maestro is going to auto-populate a string in an SBatch queue parameter. And the queue, it's going to, under the hood, use a -- partition equals something. And that's in conflict with how NERSC manages Slurm, because we don't use the partition flag to guide jobs, we use the quality of service flag. So if you do give something with a partition flag, there's a high chance that you're going to get some kind of error back that's like job parameters not supported or something like that. So what you have to do for Maestro is you have to directly give Q an empty string. And if it sees an empty string, then it omits the partition flag completely, and you can actually apply QS later and get something that works seamlessly. Yeah. Another little caveat with the example here, we've got 9 jobs in the example, and the debug QoS is limited to 5 concurrent jobs, or I think it's a submission limit of 5. So if you try to use debug with the example, you might get 5 jobs submitted and then 4 jobs rejected because you've reached your submission limit. And so that's why we're going for regular QoS here. On the main system, without the reservation, this is gonna give you a significant amount of waiting, some number of hours probably. If you're using the training reservation, then hopefully things will move through pretty quickly, and using regular here doesn't act as a hangup. Now, per step, you can define resources, and this is also going to get passed through to Slurm, and this is things like how many nodes to use, maybe you're telling it how much wall time to use, that kind of thing. So you can have steps that have different numbers of nodes or different amounts of wall time based on how much work they need to do. Yeah. Look out for YAML interpretation of colons. Okay. Another thing that is a gotcha for Maestro, there is no constraint pass-through support. They don't have like a YAML block parameter that lets you say CPU or GPU. They do have support for this for Flux, just not for Slurm. So the way that we make up for that is down in the command. The very first line that you add is a substitute SBatch constraint equals CPU. And when Maestro is putting together the SBatch script that it submits, it will auto-build all of its SBatches from its higher parameters, and then it will add this last one directly. And Slurm will still be able to interpret that as an SBatch parameter, and things will work and be accepted properly. Yeah. Workaround in the command block. Launcher and generated scripts. So the launcher value access, that is abstracting away different native Slurm or native Flux or whatever your scheduler is commands. So on Slurm, this is going to end up turning into srun, and then you give it however many tasks or processes or whatever you want to specify with your srun step. And launcher is going to give you something different if you're running on Flux, which is the equivalent to like Flux run and whatever procs. So this is just an abstraction protecting you from whatever the underlying scheduler details are. So after all of that, Maestro is building the Slurm subscript for you, and now you don't need to write these. You're in all of your individual tasks in your directed acyclic graph can get their own Slurm script built for them. SBatches automatically. So I should mention what it's going to be doing with dependencies at this point. since these things are doing S batches. Maestro, inside its process, is tracking the state of the workflow. We are not using Slurm dependency parameters. Or a Slurm dependency parameter is you say a job is dependent on some other job ID that was submitted earlier, and Slurm won't schedule that job until the earlier job is finished. Maestro is taking responsibility for that. So the Maestro process has to continue running for the course of things moving through the Slurm queue. So if your Maestro process can't be kept running long enough for the amount of passes that you need to go through the queue, then that might be a problem. So there's sort of a maximum reasonable size on the kind of campaign that you can express just by using Maestro. That was a bit of a tangent, though. So mixed execution is also a possibility here. If some of your tasks are extremely short, just like little bookkeeping things, run and grep, do a find, cat a file, something like that, then if you don't give the resources to the YAML definition of that step, then the Maestro will just run it locally. So if you're running Maestro on a login node, then it'll just run that quick command on the login node. If you're running it in like an salloc, then it'll run it outside on whatever node you happen to be running it on. All right, so progression as we're going. GNU parallel didn't have data dependencies. Signac added the parameter suite, still no dependencies. It had some Slurm help. Maestro, now we can handle data dependencies and specify a pipeline, and we can still do parameter sweep, and we've got better Slurm integration. And what we don't have, we're not great at multiple node coordination. If you happen to define a workflow that had dependencies in Maestro with independent Slurm submissions, then it's actually going to be Slurm that is handling the actual scheduling of those, and Maestro is just going to be checking behind to see like, oh, did Slurm bother to run this or not? It's not handling that directly inside the jobs. And the history reporting. Single process orchestrator. It is possible to run a very long campaign with Maestro, given the login node sort of reliability issues. Sometimes it needs a reboot or whatever. It would be plausible to get Maestro running in a container and run it in spin and have it submitting SF API calls to Perlmutter and running its jobs that way. And that would give you the ability to do a very long campaign, a very long pipeline, just using Maestro. That might be something that you could choose to do without going all the way towards running databases, running message brokers, that sort of thing. You probably actually do want to upgrade to a database running on service infrastructure at the point that you're running a large campaign, but this is something possible. This is kind of the same category as hacking together GNU parallel to run on multiple nodes at the same time. Maestro is not handling distributed service itself. It is still one process, one point of bottleneck. If you have a lot of jobs or tasks running, being dispatched by it elsewhere in the system, then Maestro will end up being the slow point as it attempts to manage and observe and coordinate the tasks that it's running. And that's another reason that you're going to want to upgrade if you're going to high scale, is if you've got enough stuff running on the system at the same time that you need multiple workers doing those individual wrangling pieces. All right, directed acyclic graph. How we model data dependencies in pipelines for almost all workflow manager tools that do so. Step, that's a named unit of work in the study list that you define for Maestro. Spec is the YAML file that defines your entire workflow pipeline, all of the steps are in it. Token is sort of the placeholder that substitutes the different terms that you need to access different pipeline pieces of information while it's running. The workspace is the outputs. Launcher is how it handles differences between schedulers at different facilities. Global parameters is how you feed parameters into the tool from the very beginning if you want to do a parameter sweep. The wildcard dependency is how you can wrangle batches of things and group them together so you only have to define one piece that covers all of them instead of defining each one individually.